Hey everyone, so in the last video we went and installed the Waterwheel on site and it went together really well. Nothing wrong with how it went together and how it was made. It all fitted together perfectly, which I was really pleased about. But there's a few little issues. One of them was the gearing was not quite right. So I got a pulley. So it was a 1-to-1 gear ratio on the belt. It was 20-to-1 on the gearbox, but 1-to-1 on the belt. But now I've upped the pulley, so it's twice the size. I couldn't get a pulley with a retaining ring on it that came like that, so I've had to machine the pulley to put a outside ring on it, but that's our new pulley. It's twice the size, so it gives us twice the RPM, which is what we needed. The other issue was the sharp curve on the corner of the trough, and the customer and his friend have actually rectified that. They've made it into a curve, and the flow around that curve looks much more even now, so that's very good. And then the other issue was the drop from the top of the trough down to the water wheel. At different flow rates, that distance changed. You know, when it was at high flow, it would jump further, and when it was lower flow, it wouldn't jump so far. And so I'm now making an angled chute, which will help direct the water into the buckets. I've got it all set up. It's ready to plasma cut, and we're going to do that today. Oh, and then I need to make a dump load controller, which is for a grid down situation. So in the event of the grid going down, the wheel would free spin. Now I've tested it and it does seem that it would be happy to do that, but obviously if the grid was down for say like all night or something, that wouldn't be an ideal situation for it to be spinning so fast all night. So what I've done is I've designed a controller which, when the grid goes down, when it loses 240, it diverts the energy from the water wheel into a heating element. So we're going to make that as well in this video, and then we shall go and fit them and finally commission it. All right, let's get to work. So these are the parts. We have two sides and a base, and this base will be curved to that radius. Yeah, you get the idea. So let's get it cut out. I'm bending it, and then the machine's sort of just smoothing the bend out a little bit. Oh, right, it's a bit of a workout, but we got it. That'll be close enough for me to form that round now, with clamps and weld and stuff. Sorted. Alright, hey everyone, it is the next day, and yesterday we managed to get this, don't know what we'll call it really, chute, nozzle, yeah, not really sure. Basically, it's just going to direct the water where we want it on the wheel, and came out really nice. It's 316 stainless steel, so it doesn't need coating, and it's going to fix, that part will fix a little bit back into the trough, and then the walls of the trough extend and support it. Okay, so the next thing I've done, just finished doing this morning, is got this enclosure box mounted and ready to go. So yeah, this is going to be a rudimentary and basic and hopefully reliable, because it's just basic, dump load controller and point for the armoured cable to come in. So here we have this gland for the armoured cable to come in. So that'll be 4 cores, 3 cores for the power, 1 for the earth. We'll have 3 phase coming into here. This is a bridge rectifier, 3 phase bridge rectifier. Out of here comes DC. I'll show you on my little drawing. So out of here, DC, which is here. This is the 3 phase and this is the DC. Out of there, the DC goes to the Solis Solis grid tie inverter, and then off to the grid. But then it also goes to a heater, which is just here. I'll move it, it's got stuff for us tonight. But it's a 2 kilowatt heater, heating element. And then we have a 240 volt to 24 volt power supply here, which gets the grid power, powers it. That holds open a normally closed relay. So the way it works is grid's coming in here, and it holds this relay open. When this relay is held, because it's normally closed, it holds it open, and so because it's open, the power from the Waterwheel goes to the Solis, because that's the path of least resistance, and off to the grid. If the grid is lost, this will close, it shorts out the terminals of the heater, and the power will then flow via the heater. So it's basically a way of keeping the Waterwheel loaded if the grid goes down. As long as the grid's there, the wheel is loaded. If the grid goes down, power cut, the relay trips and sends the power to the heating element. So yeah, pretty basic. It looks like there's a lot of space in here at the moment. That's because there's none of the big armoured cables coming in stuff. You need quite a bit of space with big cables like that. And obviously there'll be the heating elements cables going out, the DC coming out to the inverter, and it gives us a little bit of extra space for additional control measures in the future if we need them. Hey everyone, so exciting, we are back at the Waterwheel. So as you can see, I've unloaded the nozzle we made, and I've just clamped that in temporarily. Looks like it's going to work perfect. You have to excuse me if I look a little bit rough. I've only just woken up, it's still like 7 in the morning. I had a long drive yesterday. Yeah, and I'll show you something. Richard and the customer have done some work on the trough, and they made a nice curve, and it's looking really good. I'll show you. So as you can see, it hasn't been run for a while. It's full of leaves, but they've put this nice, lovely curve on the corner where we're having problems. It's made up of individual pieces of wood with individual angles. I think that looks really good. So excited to see how that happens. I think that combined with our nozzle, we should have that flow evened out quite nicely. But before we start messing around with any of that, I've got to get the new low voltage alternator fitted, the pulley and belt, and do a bit more wiring. And then once we've done that, we can start doing a bit of testing. Oh, I'm really pleased to be back here, getting this done. First job is to change this alternator. This was just left resting on. Oh, yeah. It's quite heavy. So essentially we've got the same as this, exactly the same, it's just got less windings in it, so it's lower voltage. Obviously with a with a alternator in general, the more windings of wire, the more voltage is induced, and so less windings means less voltage. This one was doing, I mean, at free spin, this one was doing over 400 volts. The new one's going to be doing more like 200. Right, let's get this. Oh, did I bring the tools? No. Right, let's get the belt off. Go. That was easy. That's good. Right, let's get this bigger pulley mounted. The only thing is, it's going to clash with this, so we've got to pull everything a little bit further out. But that isn't an issue. Okay. So that's the point that we're starting to hit, oh well, almost hit this here. I could cut this down a bit, give us a bit more clearance, but we're only 5mm off the end of here, so there's plenty of keyway and shaft in there. So providing my alternator will come out far enough, because it's on slots, so I think it will. Providing that comes over far enough, I think we'll go with that. If it does, then I'll have to take few mil off of this. Right, new alternator's fitted, big pulley. Let's see if our belt is going to fit. It is. It's a bit tighter than the old one, but it'll go. Right, new pulley and alternators all fitted. Everything's gone on. I just need to check that the case, the cover still fits over, because everything's been moved out a little bit. And then we'll do some testing. Right, so everything's all mounted, working. The cover fits. So the nozzle, if you have a look, that's what I'm calling the nozzle. This piece we made in the workshop. If you have a look, the angles are really good now. So as that bucket comes round, that bucket matches the angle of that chute. So that water's going to be filling this bucket really well without making any splashing. And then by the time that keeps coming round, it starts filling the next one. And hopefully that shouldn't do too much splashing now, or as little as we're able to do. That to me looks about right. So we're going to clamp that up now and do a little bit of testing. Right, the mill pond's filled up. We've got a bit of water coming in. John's just getting a bit more flow going. That's looking much nicer, isn't it? That's looking really good there now. Pleased with that. And the nozzle is looking great. Nozzle is looking absolutely fantastic, and the speed is much better. Look at that. That is looking good. Much better. That's right now, isn't it? Splashing drastically reduced. Much better. That's what we wanted. Working perfect. That is exactly how we wanted it, like that. Yeah, that's it. That's exactly what we wanted. Alternator spinning quicker. That's what we wanted. So everything is running really nice. I mean, look at that. I am well pleased with that. Trouble is now is that we just haven't got much water there. So that's 420 watts at the minute, but we've maxed out the amount of water we got. So we're going to go up the top and take the dam out and get a bit more water down here. You see the buckets are, well, they're not even a third full. Yeah, we're going to take the dam out. So this is the top dam, and see all that water we got at the moment is just flowing under it.
Yeah, it's going under it.
It's just under it, isn't it? So we're gonna have a go at getting a bit of this out, try and get a bit more flow. Whee! There we go. It's quite heavy, all that stuff on it. Ah. You got it?
Yeah.
It is, isn't it? Soaking. There's a bit more flow.
Got to take some weight off it.
That is heavy. There we go. God, that's got some flow rate now. So that's the main river there, and this that we're using is just a man-made leak, and these are the temporary dams. But you see, we've just increased the flow massively, so we got loads of flow now. So we're going to see what sort of power we're getting. So we've still got a bit of an issue. We're currently at 1160. I've actually had 1400 out of it, but the trouble is that it's we've reached the limit of what the alternator can do again. So it's a 2 kilowatt alternator, and it'll only do 1400 watts before it gets too hot. That's the Chinese rating system. I tend to find that things from China, not having a go, but they do tend to say that they are capable of higher outputs than they actually are in reality. And so we've got alternator issues still. So we can run it to 1400 watts, but it gets too hot. So at the moment I'm going to drop it and see about running it at sort of 1000 watts and see what the temperature decreases to. Right, I've reduced the flow rate a bit. As far as flow rate and everything goes and how it's working, it's looking really good. But it's still got alternator issues. So at that flow rate that we've reduced it to, we're at 810 watts, which is not to be sniffed at, which is still good, but yeah, still got some issues to work out. So we've, sorry it's a bit loud, obviously we're right next to the waterfall, but you see I've got it to where the buckets are filling really well now. Tiny bit of splashing, but it's very minimal. Everything's working just right. It's just that alternator won't hold the wheel back past 1400 watts. So I'll explain it a bit further. We're getting somewhere quieter, and I'll explain it in more detail. Alright, hey everyone, it is the next day, and the wheel has been running all night, like that, as a test. It's currently doing about 750 watts. Let's say it's been doing that all night. I'll go and show you. So yeah, we are at 780 watts. Okay, and we have so far, since yesterday, we have made, well, we did 2.4, and then the time switched over to new day, and 12.3 kilowatt hours and counting. So not bad, not bad. So we're running a 2 kilowatt alternator. It's going currently at least 500 RPM. We put a tachometer on it yesterday, and it was actually doing more like 600 RPM. So it's running at the correct speed. It's running at about a third of its capacity, well, just over a third of its capacity. And I'll show you what the problem is. If we come down here, it's going to get wet. So if we come under here and we get a temperature gauge and shine it on the alternator, I hope you can see that. So yeah, I hope you could see that, but essentially what I just did was put that, a laser temperature gauge, on the alternator itself, and the alternator is running at 80 degrees Celsius at 750 watts. So when I run it at 1400, I didn't even get a chance to film it because it got so hot, I had to just shut it down. Essentially that alternator cannot do 2 kilowatts. It just can't do it. It's spinning faster than it's meant to spin, making more voltage than it's rated for, and even then it can only sustain 750 watts before it gets over 80 degrees Celsius. So essentially they've basically doubled the output that it can actually do, because it can sustain a kilowatt before it gets too hot. After that it can't do it. It just can't do it. I reckon that in order to sustain the sort of 1.52 kilowatts we want to do consistently without getting too hot, I reckon it needs a 4 kilowatt alternator, because basically what they've done is they've just said it can do twice as much as it can do. You know, it should not be at 80 degrees Celsius running at, say, like a third of its output. It's ridiculous. But so yeah, I'm going to have to just put a bigger one on. So Richard's back with us. He's come here and he's been working on making some little angle pieces, just some lead-ins, rather than having just a flat edge there, just to help channel little sticks and things so it doesn't get blocked up and help the flow a little bit, which you can see it is doing. If you have a look at this side here, there's still obviously a little, it's got to still turn the corner, but if you compare that to that, it's looking much better. So he's just going to sort out that one as well, and it's going to put a bit more flow over the wheel as well. So Richard's just finished off these lead-ins, and the flow's looking much nicer around that bend. So that's looking really good. And so we just finished testing that, and now we're going to drain it again to do some final little jobs. The bend on the corner is working much better flow going around that bend. That's what we're looking at the moment. It's running a bit too fast still. It's doing about 1,000 watts there. So yeah, that was what we were just looking at there, was 950 watts. But like I say, it's just that's the most it can do before it gets too hot, so we're limited by that. We can put more water through it, we can make it do more, but it just gets too hot. Right, we're going to go and drain it now so we can mess about and do some final jobs, and then I'm going to disconnect all this temporary wiring and we're going to get it all mounted and stuff in the porch, all done properly. Right, the leak's draining it all out so we can work on it without being submerged in water. Yeah, the spillway can take an enormous amount of water. Okay, so we've got all the water bypassing around here, so this is dry. I've got our lovely nozzle, and I've got it lined up where we want it. I've moved it back a little bit to try and reduce the splashing. If you have a look, that really lines up lovely. So you see that angle there matches the angle of the buckets, and so it starts filling nicely. So yeah, I'm happy with that. So I'm going to get these cut off now, and then we'll get all this water here going back over it again. Right, we're getting somewhere now, fixed in. We get this finally fixed in with some nice stainless steel fixings, and then we are sorted. Lovely. Look at that angle, look, it is perfect. Lovely, well pleased with that. Right, we're ready to start getting a bit of water back in. Richard's done all his work down here, sealing it up and stuff. Leaks are massively reduced. Got a nice lead-ins. He's just plonking a board in there. So in not too much time at all, we shall start seeing some come over the top of here. Right, so I've got my dump controller on. So as you can see, like I showed in the video, we've got power holding open this relay. Currently the DC out of the wheel will go into the Solace inverter once it starts turning in a minute, and if the grid goes off like this, relay shuts and diverts the power to this heating element. We're just about to run some water through it, so we'll put the grid back on and we'll test that system. That angle is great. Look at that angle, it's perfect. And she'll start moving any second now. There she goes. Doesn't take much. There she goes. Okay, so we are generating very, very low. That's what we want. Can you see that? We're at 20 watts. I'm going to simulate a grid down now and check that we everything clicks off. So let's do that now. Simulating grid down. Let's just make sure we can see what's happening. Right, grid down. Right, grid's down, and now energy is getting diverted into this heater, so we'll see if it heats up. So now that we've simulated a grid failure, that's what we've got. It's showing us that the wheel is now been stopped, and anything that's producing now is going into that heating element. And that heating element will now be getting a bit warm. So this heating element currently is 20 degrees. That's Celsius, 21. So we'll add a bit more water, see if that heats up a bit, because if it does, then it's doing its job. It's heating up. I've only got it running very slow, so it's not going to heat up quick. Yeah, put a bit more water through it and then see. Okay, so this is definitely working. Running low flow, and we're now at 28 degrees. Heater's taking away that tiny amount of energy. So let's see what happens now if we put the grid back on. Back in operation. It will load up. And it's latched to the grid. 30 watts. That's 70. There you go. Oh, 280. There we go. So put a bit more water through it, and then we'll simulate that again with a bit more power. Right, I'm going to do another test. Now we're flowing a bit more water, so we've got 450 watts flowing now, and we'll simulate the grid going down. And that's the grid down. Take a temperature reading of this, see what it is. This is 29 at the moment. It heated up a bit. We'll see if that heats up even more now. Go and see what the speed of the wheel is. The next day, and yesterday late in the afternoon had an absolute disaster. Just as I was testing that grid down dump load system, I switched it on. The owner and Richard were out here, and they had a big bang, and the rod, the adjustment rod that holds the gearbox, bent because it was a sudden stop, and it ripped the belt off and stuff. Nothing's damaged, it's just a bit of threaded rod. It's all back together, but essentially what it means is my heating element that it dumps into, the resistance is too high, and because it was too high, it was a very sudden shock for it, and it bent the adjustment arm. So I need a different sized heater. I obviously got my calculations wrong, but other than that, we're all good. Everything's working right. The chute's working lovely. Splashing is greatly reduced. A little bit still, but I mean, it's, as a percentage of the flow rate, it's really minimal. Looking really good generally. It's just the alternator issue now. Alright, just come sat in the back of my Land Rover, so it's a bit quieter. Yeah, basically I just need a bigger alternator. because it's meant to do 2 kilowatts and it just can't do it. The only way I can get it, I got it up to 1400, I didn't film it, but it went up to 1400. But the only way I could get it to do that is by letting it spin twice the speed that it was supposed to. And the reason for that is the alternator can't hold back the torque at the lower speed. Even though it's supposed to be able to, we're spinning it at over 500 RPM, even at the speed that it's meant to be going at. But it still won't even go past 1200, 1400 watts before it gets absolutely cooking hot. Well over 100 degrees, 110 degrees is when I shut it down. It would have kept climbing too. So I'm going to get what the people that make them call a 4 kilowatt alternator. Even though the one I've got is 2 kilowatts, it does 1 kilowatt. So I'm going to get a 4 kilowatt one. Hopefully a 4 kilowatt one will do 2 kilowatts. Yeah, other than that, everything's done, but it's a bit annoying. So everything's all wired up properly in here. We've got it just currently just ticking over. It's just at 650, just running it low so it doesn't get too hot. The dump load and heater works, it's just that the heater is of the wrong resistance. So we need a bigger alternator and a lower resistance heater, and then we're done. We'll be in business, it'll work properly then. 1500 watts is the minimum target. It will do it. Just need to get everything just right. Oh yeah, and something else I didn't show. This end's all wired in now as well. So this is the main cable, armoured into a box, then a link over to an isolator, and then that goes over to the wheel. So shut everything down for now, because we've got a damaged belt on there now. It's working, but it's damaged, and we need a bigger alternator. It's just going to get too hot to run. So back in the workshop where we started, and didn't get as far as I'd like with the wheel really, unfortunately. We definitely ticked a few things off the list. You know, the angle of the water hitting the wheel, that's working properly. Wiring's done. You know, some positive things ticked off, but the alternator issue is still a problem. The pulley and everything, that was right. The speeds are right. The filling's right, although sometimes it is spinning too fast because of the alternator. But yeah, that alternator issue is just driving me mad. So I thought we'd take one apart and just confirm that that it's definitely not capable of doing 2 kilowatt. Then I'm going to contact the company that makes them and see if we can get them to admit that, because they've cost me a lot of time and money and made me look a bit stupid, and I've got to change the entire design of the way it all works now. So yeah, let's take one apart and see what it looks like inside. So you might be thinking, serves you right for buying stuff from China really, but the reason I went with it and the reason I trusted the output is because these are actually really well made. When you get them, I mean, they're really heavy. It's at least as heavy as an induction motor, about the same price as an induction motor. And, you know, really good, big quality shaft on them, you know, thick steel. It honestly doesn't, when you get this, it doesn't feel or look like something that's rubbish. It feels like a quality item. And I was actually confident that something of this size would actually be able to do 2 kilowatts. You know, I shorted out these terminals. If I shorted those out and I tried to turn this, and it really can provide a lot of torque. When I had these shorted out, I couldn't hardly turn the wheel around. And I was really confident that I'd do 2 kilowatt. But it definitely can't. That's the thing. It just can't do it. So let's have a look inside, see if we can figure out why. So inside, this is what they call the 220 volt, and it says it's got a rated output of 2000 watts. This is the one we took off and we changed it for a 96 volt version. And I have actually taken these apart before, and the 96 volt version had the same size windings as this one. And this is the one that got hot before, and it's actually slightly discoloured, it got so hot. But I thought I'd just measure the wire. You have a look, they don't look bad. Like, decent sized magnets. They're not just like stuck on, they're machined in. It's got bearings on both ends, decent bearings. The only thing is that the windings are a bit rough. You know, you've got the odd loose wire, but I mean, they don't look bad. The issue is the size of the wire. The winding wire, or the size of the wire in the windings, is very small. if you have a look. So we're at 0.7 of a millimetre thick wire, which is very small, and that's the issue. So I'm going to work out what the current carrying capacity of 0.7 millimetre diameter wire is, but it is not much. So just using a quick online calculator, if we put in the 0.7 millimetre wire, it gives us 0.384 millimetres squared wire. So the alternator says it's 220 volts, and 2000 watts. So if we go 2000 divided by 220, so we're looking at 9 amps, okay? That's the amount of amps. So we've got to put 9 amps through wire that's 0.7 of a millimetre in diameter and 0.3 millimetres squared. So that's completely unrealistic. I mean, that's well over 3 times as much amps as you'd put through wire of that size consistently. So we're looking at, by those calculations, we're looking at those wires realistically being able to take about a third of the output that it states on the sticker there, which is exactly what we found. We run it a third of the output, it's within reasonable temperatures. We run it at half the output and it starts to get unreasonably hot. We run it at, you know, maximum that it can even, you know, I got 1400 watts. It wasn't on this alternator, it was on the lower voltage one, but we got 1400 watts out of it, and it went absolutely roasting. Couldn't hold the wheel back, went too fast, and that's the reason. They got too thin a wire in them. I have taken the other one apart, the one that's actually in there, or one of these that, you know, a 96 volt one, and it has the same diameter wire. So that's even less capable than this one. So yeah, that's our problems. Let's go and speak to the people that supply these things and see what they've got to say for themselves. So this is the store I used, Rewind AGIC, I'm not sure how you say it, but that's the store. So it's a factory via AliExpress or Alibaba. You see, I start by explaining that I've received the alternators, I've installed them, tested them, and then they don't work. You know, they get too hot, and yeah, and I'm explaining them that I'm going to tell them that I'm going to show it on YouTube. They get back to me and give me a load of nonsense, a load of rubbish. I mean, you can read it yourself, but they're essentially saying that it's completely normal for it to generate heat. Obviously, we know that's true, but not excessively and not at the correct outputs. So, as I say, the generator is not fit for purpose. It can't do 2 kilowatts without overheating. The wire size is just simply too small. It's come back with still just nonsense, really. Do you want to return it? I can't do that. It's damaged now. So I now go on to, can you give me the real honest output numbers of the alternator and models you sell? I don't want made up numbers. I know they're exaggerated, so can you please tell me the proper output models are the ones you sell, the real output numbers? And here we're finally getting somewhere. They come back and they explain that the 2 kilowatt is just theoretical rated power. In fact, the actual power is much lower than the theoretical rated power due to many factors, but there is still no problem outputting power of several hundreds to 1 kilowatt. Thank you. So they suggest then that I run the generator at 500 RPM, which we're doing, and the output power at this time will be 600 watts. So there we go, we're getting to the bottom of it now. So we've gone from 2 kilowatts to 600 watts, which is exactly what we've found. So then I said that, you know, they're lying to their customers. It can only do 600 to 800 watts. If I wanted an alternator that could run at 2 kilowatts, which one would I need? And they said they sell a 5 kilowatt one that will actually work for 2 kilowatts. So obviously I don't trust that at all, and I'm not going to buy that, but I thought I'd just push on a little bit more. So I said, right, we're getting somewhere. So the 5 kilowatt model will run at 2 kilowatts. And then they say that, you know, they're the lowest price on AliExpress. We sell it cheap. They don't make a profit. So we need a bigger generator with more price, which is fine. I would have just paid more for a bigger one if I'd have known that. Wouldn't have been a problem. I don't mind paying, you know, more money for something that is better and worth more and rated properly. But now they've just lied, so I won't be giving any of them any more money. So then I go back and I say, explain that they've cost me so much money, time, made me look stupid, and you know, they explain that some sellers actually sell this same 2 kilowatt one as 10 kilowatts, and so they're not as bad as some people. Then I went and thought, oh, actually I'll investigate that then. So I found a 10 kilowatt one, and I thought the best way of checking to see what size this was would just be to compare the dimensions. So this is a different factory now. As you can see, I've got lots of different factories there. They're all selling the same thing, same rubbish. And so I asked them the dimensions and the wire sizes. He sends me the drawing for the dimensions, which is exactly the same size as the one you've just seen me taking apart. And so it's physically impossible to fit something that can produce 10 kilowatts inside that frame size. That's just not possible. I explained that to him, and he says, or she, whoever it is, yes, you are right, and the 10 kilowatt generator is very expensive, insinuating that obviously that isn't a 10 kilowatt generator. In actual fact, this product here they're calling a 10 kilowatt generator is actually the same size as the 2 kilowatt one I bought, and the 2 kilowatt one I bought is actually good for 600 watts. So that's what we're dealing with. So there we go, that confirms it. The suppliers of them have admitted that they can only really run about a third of what they state they can, even though they're these big chunky things, big chunky output shafts, big magnets, all that. Everything's there for them to work right. They just run too small a wire. And so in reality, they can do about a third of what their output is. Now you might be thinking, well, just buy one that's 3 times the size. But as you can see, some of the people that sell them sell ones that are 3 times the size on the label, but are actually just exactly the same model. So some suppliers sell that exact same one, this 2 kilowatt one, exact same form, exact same size, as 10 kilowatts. I've even seen that one sold as 30 kilowatts. So essentially, can't trust anything they say. It's all a load of rubbish. It's absolute crap. They can't label them correctly. I can't even find one even incorrectly labelled that's big enough. So we're going to have to go to an induction motor. Now, if I use a 8-pole induction motor, that will work with our new faster RPM, so that's fine. It doesn't fit inside the guard though, that's the main issue. So I've got to now modify the mounting plate, modify the guard, modify the wiring, and buy a 8-pole induction motor, which is 600-700 quid on its own. Different pulley again because the shaft diameter will be different. Basically, I've got to change everything related to the alternator just because they can't label something correctly, which is really irritating. But really, the only person I can blame is myself for trusting it in the first place. So yeah, that's the next job, is to adapt everything now to run on an induction motor as a generator. Gonna have to put capacitors in. I've got to change everything. Yeah, because I made the mistake of... Yeah. So yeah, that's where we're at. So that's going to conclude the video, and in the next one, hopefully, we'll have this problem sorted. All right, hope you enjoyed it. Thanks for watching. See you later.